Alright, so looking at the arc length formula, and this is one of the situations where you're going to have to use radians. I'm going to put it in big letters here. Okay, and one of the ways that I know that is that the formula actually has theta in it. So you see that here, that little symbol there means theta. That means I have to use radians. So the formula will help you to decide whether or not you need to have it into radians or degrees. If you see a theta, you need to think, oh, damn, I've got to put that into radians. So in this case, what this actually means is the radius for r times the angle. That's what the theta represents, and this is in radians. So the formula is actually quite simple. It's just multiplying two numbers together, but we need to make sure we've got that information in the correct format. So as an example, if I have a circle, and I've got a radius of 8 centimeters, so I can draw on the radius. Remember, the radius goes from the center to the edge, so that's one thing to remember here if you don't remember. The radius is from the center of the circle to the edge, and the diameter is the whole way across. Okay, so the radius is 8 centimeters, and the angle is 1.2 radians. So 1.2 radians, I'm gonna say it's something like this, just estimating 1.2 radians. That's my angle. So this is the type of problem I'm looking at here. Calculate the arc length. If the radius is 8 centimeters and the angle is 1.2 radians. Now the arc length, what the heck is that? That is actually this here. It is the length of the arc that is described by that angle. So kind of like how long the piece of crust is on the piece of pie or the piece of pizza here. So again, the arc length is just the length between the angle there along the edge of the circle. And sometimes we need to know that as a distance for certain problems that we have to solve. So looking at this question, I can see that the radius is 8 and that theta, the number of radians, is 1.2. So my arc length will be equal to 8 times 1.2. And that is 9.6 centimeters. So that tells me that it's 9.6. From here to here is 9.6 centimeters. So if you needed to know how long a piece of fencing needed to be to block off that part of an irrigation paddock, you could use the 9.6 and the arc length formula here to figure that out. So let's look at a few other examples here. Number 2. Calculate the arc length if the radius is 12 centimeters and the angle is 83. So again, I'm not going to draw pictures out for all of these because we don't necessarily need it, but r is equal to 12 and the angle here is equal to 83. So my arc length is going to be equal to 12 times 83. Uh-oh. See, this is where you have to stop and think, oh no, that's in degrees, so you should be thinking, oh, hang on a minute, I've got to convert that, because degrees won't work. Remember, the arc length is radius times theta, and theta has to be in radians. So our first step here will be actually to convert that to radians. So to do that, if you remember, 83, we're going to times it by pi over 180. And if you times it by pi over 180, you get 1.45 radians. So now we can plug that into our formula. So 12 times 1.45, and my arc length is going to be then 17.4 centimeters. So keep that in mind. Watch out for it. If you've got degrees, you need to make sure you convert to radians. Okay. Calculate the angle at the center of the arc for an arc of 12 centimeters in a circle of radius 15 centimeters. So calculate the angle. Oh, well that's weird. That's actually this. That's what they're wanting us to find, is theta, that angle symbol. So they want us to know what the angle is at the center for an arc. Well, this is actually going to mean the arc length. So we could say that the arc length is equal to 12, and the radius here is 15. So maybe we will draw a picture for this one. They're saying I've got a radius of 15. I've got an arc length of 12 centimeters. And they want to know, what's that angle? So we have to do just a tiny bit of rearranging here. If you keep in mind, arc length is equal to radius times theta. So to rearrange it here to find theta, we will divide by the r. So theta will become arc length divided by r. So in this case, our angle is going to be 12 divided by 15, which is 0.8 radians. Because we're talking about radians here. We've solved it using the arc length formula, so it's going to be in radians. But the problem has asked us something else. And watch out for these tricks. Give your answer in degrees, which is unfortunate. So we still need to convert it back out. So, I'm not leaving myself enough space here, sorry about that. To convert the 0.8 radians into degrees, let's do that here. Remember, if we're going from radians to degrees, you're going to times by 180 and divide by pi. So in this case, you get 45.8 degrees. So that's the way that one works out. So again, watching out for that, they actually want the answer in in degrees. The formula will give it to you in radians, and you'll have to convert it out to degrees. Looking at number 4, calculate the radius. Okay, so here they're actually wanting us to find r of a circle of the arc length. So the AL, the arc length, is 60. And subtends, that's just a fancy word for meaning the angle is 40 degrees. And if I read this out loud, I'll catch myself saying the word degrees and think, oh, damn, gotta convert to radians. So that might be the first thing I'll do, is take the 40 degrees and times it by pi over 180. And that will give me 0.698 radians. So now I know what my angle is. My theta in radians is 0.698. And from here I can take now a look at the arc length formula. So I know that the arc length, abbreviating it as AL, is equal to r times theta. And they want me to solve for r, so what I need to do is actually divide here. So the arc length divided by theta will give me the radius. So here I'll have 60 divided by 0.698 is equal to 85.7 centimeters. So my arc length is equal, my radius is 85.7 centimeters. And some of you might struggle a little bit with your algebra, so let me give you a little formula cheat sheet you can use here. So if we know that the arc length is equal to r theta, you could use one of these little formula triangles, like we used to do for sine and cosine, where you're going to put the arc length up there, the radius, and theta. So that's one way to try to memorize with this how to rearrange that formula, knowing again that you can use your finger to cover up one. You would divide going down and times going across, so that could be a formula triangle for you to use. If not, you could just try to memorize the hard fast rules that we've talked about here in these last two problems. The radius is equal to the arc length divided by the angle, where the angle is equal to the arc length divided by the radius. And then we've got the original formula that was just the arc length is equal to r times theta. Those would be the three formula you could use.